Abstraction barriers separate different parts of a program so that each part only needs to know so much about the rest of the program. Now, these separations are important because they allow you to make changes to one part of your program and have other parts take advantage of those changes without breaking in any way or creating inconsistencies. So let's talk about the abstraction barriers in the development of a rational arithmetic system that we've been working on for this lecture. So there's a part of the program that uses rational numbers to perform computation. So I actually want to know what's 1/2 times 1/3. In those cases, we're actually treating rationals as whole data values. They just represent some number. We don't care how. We just want to know what happens when you multiply these things together. And in order to do that, we use certain functions that are part of the data abstraction for rational numbers. Add rational, mul rational, rationals are equal, etc. are all things that take in rational numbers and do things with them, perhaps returning new ones. But using these functions doesn't mean you need to know much at all about how rational numbers are represented. In a next layer down, where we look at the implementation instead of just the use of these arithmetic operators, we find parts of the program that create rationals or implement rational operations. And they treat rationals as a numerator and a denominator paired together. Now, they may not need to know exactly how that pairing happens, but they do need to know that a rational number has a numerator and a denominator. These two things can be selected. And they need to know that you create a new rational number by combining a numerator and a denominator together. And these all happen using the functions called rational, numer, and denom. So I drew a really thick line right there to represent an abstraction barrier. That barrier says anything that's using rational numbers to perform computation should only do it in terms of these functions and should not be using functions of a different layer. In this way, the programs that we write make as few assumptions as possible about exactly what representations we're using, and instead obey the abstraction that has been set out by the programmer. So what if we go one layer down from that? Well, there are parts of the program that implement selectors and constructors for rationals. And those implementations of rational, numer, and denom treat rational numbers as two-element lists. So they do understand their whole data values, that they're consisting of numerators and denominators, and then we have a further detail that the numerator and denominator are glued together using a list. So for this, we use list literals and element selection. And again, there's an abstraction barrier. If we're in the business of creating rationals or implementing rational operations, we shouldn't need to know that we're using lists under the hood. And we shouldn't cross this abstraction barrier and use a list literal or element selection directly. Instead, if we write our programs in terms of just rational, numer, and denom, then changes to those functions later will be propagated throughout our program. And we could, for instance, start expressing every fraction in lowest terms. Now, is that it? Well, actually, there are many layers of abstraction in a program, and there is stuff that's even lower detail than what we've seen so far. So lists are somehow implemented in the Python language. We don't really need to know exactly how that implementation works. All we need to know is that lists can be created with list literals and taken apart using element selection. And so any place where we're implementing selectors and constructors for rationals shouldn't worry about the implementation of lists. It should just know that lists can be created and selected from. So each big line is an abstraction barrier, and you should know that when you're writing one part of a large program, that it should use the level of abstraction appropriate to what you're trying to do. And the higher you stay up, without crossing of these boundaries, the easier it will be to change your program in the future. So let's look at an example of violating abstraction barriers. So I've said add rational, 1, 2, and 1, 4. So a half plus a fourth should give me 3/4. And under the code we've written, this will work just fine. I have a definition of dividing a rational, which returns a list of whatever is the 0th element of x times the first element of y. And then we have the first element of x and the 0th element of y. Again, in our current implementation, this will work. No errors will be raised. And yet, we've done something terribly wrong. We've violated abstraction barriers. So for instance here, we've assumed in our use of add rational that a rational is represented as a list of 2 integers. Which means if we went and changed the rational constructor, it wouldn't be used in this block of code, because I didn't actually call rational here. So I did not use constructors. Is that so bad? Well, it's pretty bad, but it gets really bad when you see that it happened twice in a row. Okay, now I'm getting angry. That's unacceptable that you would just violate abstraction barriers like that. I hope we're done. Uh-oh. Down here, we're dividing rational numbers, which should treat rationals as numerators and denominators, but not necessarily assume that they're lists. So instead of using the numer selector function, instead I've used the element selection that works for lists, thereby assuming that x is a list. Instead of saying, oh, it's something that has a numerator and a denominator, but I don't know exactly what it is. So, I've gone down to too low of a level. And oh look, I did that 4 times and then I returned a rational number, but again, I did not use the constructor called rational to do it. This is not okay. This, if I saw somebody's computer with this code on it, I think I would honestly just light it on fire and just watch it burn. Because code that violates abstraction barriers should burn.